In this video, we're going to be talking about comparing graphs when we're going to be transforming a graph and when our graph, our base function isn't a parent function. It isn't one of the general functions. So what we have here is a little reminder of kind of like how transformations work and what certain things do in certain places. Now, even though this is a quadratic function, it will still work with our cubic function just the same. So as we look here, we see that we have an h of x, and then that h of x means that we're going to be doing this to our f of x. Now, our f of x is our base function, or kind of like our parent function, if you will. And so this is where we start. Okay, that's going to be where we start. So what we're going to do is right here where we have our x, so that's really dark. Let's try a different color. Right here where we have our x, notice here we have a 1/2 of x. So we have a 1/2 of x. So what that means is that in this x's spot, we're going to put a 1/2 of x there. Now notice that the 1/2 is inside with the x. So that's going to correspond to what we see happening. Oops. There we go. So that's going to correspond to what we see this a value right here doing, which is a horizontal stretch or shrink. So because we have this 1/2, I'm going to go ahead and I'm going to circle that in our green, this 1/2, right? Because we have that 1/2, we should expect to see a horizontal. Now it's a fraction, and it's smaller than 1, and so that means it's going to be a stretch by a factor of 2. Because remember, when it's on the inside, it's like it lies to us. It's like a hypocrite. And so it says one thing and it does another. So it's going to be a stretch by 2, a horizontal stretch by 2. And that's going to be what changes we see here. So that's going to be our original equation. And then our new equation is going to be a horizontal stretch by 2. So let's go ahead and let's set up to kind of sketch this and see how that looks and make sure that we're right. So the first thing we're going to do is we're going to graph our f of x equation, which is 2 minus x to the third. So to do that, we're going to use our calculator. So we're going to go ahead here and clear out what's in there. So we're going to type in 2 minus x. Let's scoot this over so you can see all the buttons. 2 minus x raised to the third power. That's our parent function, and that's what that parent function looks like. Notice here that it crosses at 0, 1, and a little bit past 1, 0. So let's go ahead and let's just kind of sketch that. And again, we're just kind of doing a quick sketch. And so we know that we had 0, 2, and then just past the 1, right? And it looked like this. Let's just double check and make sure that we've graphed that appropriately. Yep, so we have it decreasing from left to right, just like we have there. Now, a horizontal stretch means that we're going to kind of grab our pieces and pull them away from the y-axis. So it should look like it's a little bit wider of a graph. But you'll notice that this point, this 0, 2, won't move. That's where that point will stay. So let's go ahead and let's plug that into our graph. So, well, what does that look like? We need to know what the equation looks like. So we need to take our equation. So let's see, for h of x, we'll have our equation 2 minus, but we're going to take the x out, and instead we're going to put that 1/2 x. Remember we talked about that? About how we need to plug that in to the x's spot to do it? Then we're going to go ahead and plug. We can either plug that in just like we see it, or we can, that's really the easiest thing since we're just comparing. Let's just plug it in as we see it. So we're going to go ahead and go to our y equals, and we're going to plug in 2 minus, and then in parentheses, we need to put that 1/2, then we have x, then we're going to close our parentheses, and then raise all of that to the third power. Okay, raise all of that to the third power. So our red graph is going to be our h of x. So we're going to graph that. And notice that it's wider, right? It's pulled farther away from our y-axis here. We have that same point at 0, 2. So we have 0, 2, and then we have just past 2 and 0. So just past our 2 and our 0, and we still have our point 0, 2, and we know that this is going to come out wider and then come down. So here we have our h of x, and here we have our f of x. And so we can see that this has been a horizontal stretch by a factor of 2, and that this, oops, is what our graph kind of looks like and resembles, right? In order to do that, we had to plug in our 1/2 x into the x's spot.